Recording in recording in progress.
All right. So it's recording. So like I said, I need everyone to come in to class April 21st, April 26th, April 28th. Okay. So that's why I'm recording that part. You need to come to class. No Zoom presentations, please. Okay. April 21st, you need to come in so I can just see your projects. I'll sit with you guys, just me and your groups. You need to kind of tell me where you are on project A, project B. This is your final opportunity for me to give you, some help, some pointers on your presentation. Then you'll do your presentations on April 26th. That's the plan. Okay, you need to do demos up here to the class for both projects, project A, project B. There is no real order. It's first come, first serve basis, but you'll need to demo, your Hadoop cluster, just kind of, show evidence that you did it. And then also your topic of Linux. Remember, each one of these is worth 5% of your grade. So project A and project B. One just tests your skills with Linux. Basically, you're putting everything together. The other one is really an opportunity for us to look at other new topics that I may not have covered in the class. So like Docker, for instance, that I'm doing. Okay, so that's basically the plan. And like I said, so one last lecture, project, me kind of looking at your projects, work on labs kind of thing. Then here, project presentations. I always usually save April 28th as a wrap up, course wrap up. If I did produce enough content for the Docker lecture, I might do a little bit more on that day. It just depends on how that goes, but usually this day is just meant to be last day to catch up on anything. Homework assignments, I think the last one was the Unix firewalls, I believe, right? That was the last required one. And I said, I will talk about a lab here for file system analysis. I'll kind of go over it and give you the gist of it. But I think we made that one bonus points if you're interested. Yeah, and then that's it. And then today I'm just going to do some miscellaneous scripts in Python. We're going to explore a few last things related to services or Unix in general, little nice handy things that could be helpful. So that's really the plan. So before I get started then, let's see, are there any questions on anything? Any issues with the homework? The last homework, I think, was extremely easy, right? The UFW firewall. How many of you have completed that assignment? No? When is it due? It's due this Saturday, right? So it's not supposed to be. Okay, yeah. So I think I haven't seen that many questions about it like I usually see in other labs. So that tells me that it hasn't been as hard. All right, so that's good. Today, as I said, no homework. Just miscellaneous script, follow along, practice. These should be interesting. So I would imagine that you would try them out on your own. All right, so let's do that. So I'm going to go ahead and start the virtual machine here. I'm not hearing any questions. And then, as I said, I'll be grading the exams, hopefully. By Tuesday, a good chunk of them will be done. All right, so I'm going to go ahead and start the VM. So we're just going to use one VM for this. It's just simple scripts, but we're going to be interacting with some services. Basically, that's the general idea. Let's go ahead and start the virtual machine. scripts are already on GitHub, so you can just get them from there if you would like to just get the running code, but I'll kind of go over it. All right, so I'm going to share this screen here. Sharing the screen. So you should be seeing the CVM using it. All right, so there's some scripts in here related to zipping files, Linux, SSH, and HTTP, creating files in a nice format like PDF. I'll talk a little bit about Git. Are you going to do the Git for your project, Noah? Probably. I'll talk a little bit about it. Then maybe you can tell me what you're doing. But yeah. I'll talk about something called Anaconda. How many of you have heard of Anaconda? Anaconda, you've heard of it? How many of you have used Anaconda? You have? All right, good. All right, so I'll talk a little bit about that. As I said, just today is just a whole bunch of things I'm throwing at you. Maybe it's, one thing about these things is like, they might be really things that you think, oh, that must be really hard. And actually 10 minutes and you're good, okay? So, so that's really the idea. So we'll talk about some of these topics. All right, so let's talk a little bit about, all right, so everyone should be seeing the virtual machine. All right, there we go. So that's the terminal. So let's see which one should we talk about first. Right, so let's start with Git. All right, so I'll start with this, and Noah, I'll pick since you're doing this project. All right, so what is Git? So Git is a system that allows people to collaborate when they develop code, basically. So if you go to any organization where you're doing software development of any kind, they're going to want you to use Git. All right, so we're all familiar with GitHub. There's also this thing called GitLab. Some organizations actually use GitLab because it's more of a restricted, private kind of a thing. So that's something that's available in an organization, and they may ask you to use that, right? And instead of using, but it looks exactly like GitHub pretty much. It's the same. So if you've ever used GitHub, you'll have a sense of how that works. So the process, just really quickly, how it works. Usually what you would do is you would go to, let's say, I'm going to open, hopefully I have internet access here. So I'm just going to open GitHub. Actually, I'm going to open my own. You're familiar with this because, I use it all semester to find scripts. So I have a GitHub, create a GitHub profile. Right, and then in that profile, you have basically your repositories, right? So notice I have 13 repositories here for various things, various code, including, for instance, I have a repository for this course, Unix and Python scripting, for instance. Everything in the course is usually there. So how does Git work? So Git is this idea that you have, let's say that you want to create a project, right? So all of you, let's say the 5 of you are working in code development of some kind, and you've been tasked with developing something. It could be anything, like a website, for instance, and you're all writing PHP, HTML, CSS, JavaScript, and so on, and other possible environments. So then what's the idea? So you're going to create a project that you're all going to share in, right? So you're going to go in and create this project, something like this. And in this, you have your different files, etc. Right? So you create the project. You can create it on the GUI interface, for instance, right? So really what that means is you create a name for it, and that's it, right? And you can put like a README file in there. Now, how do you get then to work with GitHub? Now this repository has been created here, right, in GitHub or GitLab, and all of you want to collaborate on it, right? So all of you have laptops. Let's say you're all using Macs for the sake of argument, and you're going to go to the terminal, right? So the key thing you'll have to do is you'll have to establish like a secure connection, right? So usually what that means is you're going to download a key from here into your computer's environment, like an SSH key, right? And that's how you do the authentication, a username and password from your environment. So basically the credentials that you have here, you're going to have to set up the first time around when you install Git, okay, when you're using Git. Assuming you've now established, your keys and everything, every time that you update something from your Mac or your computer to this Git repository through Git, you're going to have to type in like your password, right? So it'll probably remember your user, but you still have to, type in your password. So that's basically the idea, all right? So that's just configuration in the environment. And then the sequence of commands that you're going to use is actually quite interesting. So let's say that, let's say Nikita, you're going to start working on the project, right? So right now, none of you have this on your computers. You've only created it on GitHub, right? So you only have the Git or GitLab, the repository there. And so what are you going to do? You want to start coding. So the first thing that you need to do, you've already established your user, you can authenticate and everything. So what do you need to do? You need to download that folder, right? It's almost like you need to download that instance on GitHub to your computer. You guys see that? That's the starting point. And so basically to do that, you're just going to go, we usually go to, you're usually going to go to, what's this thing showing weird? So, well, actually, what am I doing? I don't need to do this on the, let me just do this outside. I'm going to share this screen. All right, so I'm here. I'm going to go to my, okay, I'm going to go to GitHub. You can see, you should all be seeing GitHub here. All right, and then let's say that you pick some repository. I'm going to go to the Unix repository. And then here you can see I do this, right? I do that, and that gives me the URL that I can download, right? So this is the repository itself. Does this make sense, guys? And just imagine, none of this is there, right? All I've done is like created a README file, but I created the folder, right? Which means this instance already exists on GitHub or GitLab. So now all I need is this URL is what specifies that repository. Does that make sense? So now, let's say Nikita is going to be the first one to develop code, but then all of you are also going to do that, right? You want me to click on, where is that? That one? This is with the Git command. This is with, that's basically it. So it's like, there's no difference, basically. You can actually do Git clone this and it'll work. Or you can do Git this thing here. It's almost like it's a slightly different connection. Yeah. There's no difference. You see what I'm saying? All right. So basically here then, this of course assumes you've already established like the user, credentials and everything, right? For it to work. So now I have this, as I said, you've created the folder. Now you have this URL, right? And this is the URL that you're all going to collaborate in, okay? This is the URL. So I'm not going to copy it necessarily, but just imagine that's the URL. You can just click on this little button here and it's copied, right? So you have it there. I don't know if it'll transfer to the VM, but so now let's go to the VM. I'm not, I don't want to create this in the machine, but what you would do here is, let's see if it'll, apparently it didn't, doesn't matter. So that's the URL that I copied over there. So what you would do is you would do a git clone and then that address that you just downloaded, right? So ... Do you see that? When you do that, that thing that you have on the GitHub, you know, you're gonna clone it to your machine. And so now you create it, right? And all of you can do the same. You see that? So all of you can go in, download it, and start working on various different files of this. What's gonna happen is once you all start working on the same Git environment, every time that you go in, you're gonna type, let's say you cd into the environment, right? The repository. And now you're gonna say something like git status. And when you do git status, it's gonna tell you, hey, this has been modified, you need to pull. And what that means is that, let's say, what's your name? Sorry? Aaron. Let's say that Aaron did some coding last night, right? And then Nikita comes here in the morning and is about to, oh, I'm gonna do this coding, but Aaron did some work. And so when you do git status, it's gonna inform you that the repository has been changed. Does that make sense? It's really nice. I mean, it's like really neat. And so when that happens, what should Nikita do? Nikita's just gonna go in and say, ah, okay. So I'm gonna like sync them, right? I'm gonna sync. So you're just gonna do git pull. Does that make sense? And by doing this git pull, you're now downloading the updates that Aaron did to your environment. So you'll probably want to do that. You don't have to. You can, you know, but you probably want to do that just to feel that you have a fresh copy of, especially if you're not working on the same files, then it's no problem. Do you guys see that? So you do the git pull. Let's say that now you're all in sync and you've done the git pull, and you know all of you are doing that, and you're working on different files. Like some of you are working PHP, CSS, JavaScript, HTML, whatever. So you've all done that. Now let's say that Nikita then at 9 a.m. started doing this, starts working, and now he's done a lot of coding, right? And it's the end of the day, maybe. Obviously, some people want this stuff that, for you to send the updates like every 2 hours, comment everything. Most people, I think, just wait until they feel that they have something worth, accomplished and to do it, right? So let's say at the end of the day, you felt like you wrote a couple of functions, you're pretty proud of that, you think they work okay-ish. So now go ahead and you want to update the repository, right? And the usual sequence is actually pretty simple. So the git commands, it's only like 10 commands. There's literally it's not like there's 150 commands or 1,000, right? There's like 10 commands in general that you're going to use at most, okay? And so then now let's say that you've made your updates and you're ready to update. So how do you do it? So you're going to go in, again, you usually do a get status, right? And that's just going to say no one has made updates, right? Because otherwise you'd probably want to do a pull, right? A get pull. So then let's say you're the only one working on the repository right now. You look at status, and the status is just going to like highlight in red, and it's going to say, oh, you modified these files. Maybe you ran some of the code, gave you some output, some results, whatever. That also is going to appear there. So you do the get status, and okay, yeah, I made some changes. Now I'm going to do git, and then you can do git add. And I usually just do git add -a. I'm kind of lazy that way. But you can also do git add specific files with specific comments. Okay, so like, oh, I added this file, and I know, this was for this, and I added this file. Git add -a, basically it adds everything, and so that, the disadvantage to that is you're just putting in one generic comment for all of it. But I like it because like I won't forget a file, right? So I don't have to remember the file names, etc. But git add .a will kind of just do like you added them, but they're not yet on the website, right? They've just been added, let's say, for you to send them out. So then the next step is usually to do git commit. And then here is where you probably want to put in a message. This is, a lot of people want you to do this. So you're going to say made this change, blah, 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 right? Something like that. So that just means that that's the comment that you're putting in there. Something short and descriptive, but it kind of says, maybe if you've met a milestone or something like that, you say, oh, I finished that function. That was, or corrected this error or updated or something. All right, so then this would be the next step. So you do git commit -m with the message, right? And you hit enter. Then after that, the last step is to do a git push. And that's usually when now the data will be sent to the GitLab environment. When you do this git push, this is where it's going to ask you for the password. So usually you're going to have to type in whatever your username password is, and that'll allow you to write, because you're writing to the repository, basically. Obviously, you can usually, there's some kind of a administrator that will manage all this, and they have to give you the permissions to get in there, or you can confirm this. If you're doing this like on your own personal GitHub, you do all of this. If you're working for, doing an internship or whatever, somebody's going to give you the credentials, obviously. And that's it. Believe it or not, I mean, that's the sequence of commands. So if you think about it, that's under. There's a few other ones, but basically, it's about 7 to 10 commands, and that will be your workflow. And it's not really that complicated. So if you've ever been scared of, like software development, and in particular, this idea of like, oh my God, how am I going to do this Git? It's trivial, actually. And you're going to love it. I mean, you're going to love the fact that it really syncs up people's work really nicely, because it even warns you, right? So it's like, you're about to do a push, but it's gonna, push, but it's gonna say, wait, do a pull first, because something has happened. And so that will work like that. And that's it. That is Git. Any questions? Does that make sense? Noah, do you have anything to add? Or are you gonna? No? Yeah, that's about it. That's what you're gonna demo. All right, great. Yeah, so yeah, that would be nice. That will be nice. Put in some files, right? Create the account and demo that. But yeah, good. All right. So as I said, I just, today is just miscellaneous topics. So that was Git. So hopefully you guys will be a lot less scared of it. There's a video on YouTube that I had for this, but if I remember, I'll add it to this and you can just find it. It'll show some examples of it. All right, so that's Git. The next one that I have in the let's go back to. All right, so the next sequence of so all these, if you go to Git commands, right? That's where I have them. So if you want to just get them from there. All right, so conda commands. So let's talk about that one a little bit. What? All these files are stored on GitHub. You mean like in my repository specifically? Yeah. So remember how Git works. So you have the files also on your local machine. So that's why I said, so when you start the project, right? Let's say that you're in your desktop, right? And that's where you want to have your files. So the first step is to go to GitHub, create the repository on GitHub itself. That's probably the best thing that you can do. And put in a README file in. Do you know what I mean? That's it. You just do it like on the GUI to start the project is the easiest thing. Then you go to your folder on your terminal, wherever you want. Let's say on desktop, you create my work folder. You go into that. And when you're in there, you invoke Git Clone and the URL of the repository on GitHub. So what that will do is it'll create a folder with the same name and the README file, and it'll appear locally on your machine. Do you understand? Yeah. You said there was a second version of this for companies who don't want to use GitHub, yeah. GitLab sometimes. GitLab. There may be others, but which other one? Yeah. So it's, I mean, I'm sure there's a lot of them, but ones that I know, right? That I know is either, yeah, GitHub obviously is like the public one, public facing. GitLab is just like a private solution of the same thing. It's probably owned by GitHub. I'm sure if it's owned by, I don't know who owns it. I assume GitHub owns GitLab, and it's just like a private solution Like, you know, somebody went to GitHub and said, hey, we want to have something but in-house. Can you help us with this? And they're like, sure. Right. And they created GitLab. But yeah, it's the servers, you know, the servers are probably AWS. So they spin them up, spin them down whenever they feel like doing things, you know, in the cloud. Does that answer your question? Do you have an additional question?
I was thinking, what if somebody didn't want to host all the code on here? Is there a way to do it on their own internal servers to use the same type of tools?
But use the same type of, you know, that's like a GitLab kind of thing. I don't know that, well, you could create your own Git, but, or there may be some open source ones, but they're going to be buggier, because if you don't have people supporting it, right? Every time there's an update on a server or something, the thing may break. So I think for the most part, companies will just go with something like GitLab or something similar, something that's supported. Because it is nice. And the point of this lecture was to convey to you guys that it's easy. You can get up to speed with Git. I mean, if you're slow, reasonably in like 2 hours, if that makes sense. But you can pick it up really quick because it's just this, you know, it's just that. Oh, sorry, you're not looking at it, but it's just this. I don't know. So it's just that sequence of commands that I had given. Apparently my internet stopped working. Anyway, I don't know. Any other questions? Nope. All right, good. So I'm losing. All right, so let me see if I can share this. All right, so as we were talking about, this is a Unix class, you know, Unix. So these are things, these are tools that you're going to need, right? So, you know, depending on what you're doing. And that was a brief introduction to Git and how to do version, you know, that sharing or collaboration of software development. The next tool that we're going to talk about is Conda. How many of you have used this one? Anaconda environment? Some of you? All right, so yeah, so what is the Conda environment? So it's basically a way, it's very nice actually, very neat. There are other solutions also, but this is, you know, what have you learned about Linux? You've learned that you have to do apt install, right? And, you know, it used to be in the past that you first, before installing the actual program, you had to install all the dependencies and you had to do that manually, right? And then you had to do updates. And then now you did this update and everything broke, right? So you have 20 projects, you're working on the latest project, you do an update on the whole system. The latest project now works, but guess what happened to the other 19 projects? They stopped working. Yeah. And that's a big deal. Okay. So that's the problem there. So Conda or Anaconda kind of solves this problem for us. Okay. Because now what you can do is you're going to create a virtual environment. So every time that you want to have a setup of a project, what you do is you create a new virtual environment. And all the dependencies and all the programs in that virtual environment are specific to that project. So let's say that you're using Java 2 and you need Java 2 for that project. But then you get another project where you need Java 3. Well, what do? If you don't have Anaconda, you have to upgrade to Java 3, but then the stuff that needs Java 2 breaks. Do you see that? That's a problem. So with Anaconda, what you can do is now you create multiple environments. Okay, so you're going to create multiple environments. In one, you can have Java 2 for your Java 2 files, and they're going to work perfectly fine. And then in another one, you have your Java 3, and they're going to work perfectly fine. And if you want a Java 4, you create another virtual environment. And if for some reason you have to go back to Java 1.5 or create another virtual environment. Do you see how nice that solution is? Yeah, and so that's really great. And so the thing that you have to do for that one first is you have to go to the Anaconda website. So this is used extensively in data science and other areas, but where you have a lot of files. So you go in here and you're going to have to, of course, install. There's going to be your versions of Anaconda for Linux, Mac, and Windows. So it works really well for all of those, really nicely. Okay. Where is it? There it is. So it's currently what's happening is it's detecting that I have Windows, so it's only showing this. But you can see here you have your Linux and Mac. Okay. So the first thing is you just follow the instructions to install it. Okay. So you just follow the instructions to install it. Once you've installed it, then it becomes straightforward. So I've provided the commands there, basically. So assuming you've installed it, now you're going to use all you have to do is use the conda command. Okay, so you're just going to use the Anaconda command. So again, as you can see here, basically about 10 commands after installation is all you need. You don't really have to have sudo or privileges or anything like that, right? Once you're in the conda environment, it's an environment within Linux, so it's its own thing. So let's take a brief overview of this. As you can see, it's also straightforward. Let's say now you have your conda environment. So the first command that you usually run is you're going to do conda environment list. Okay. And what conda environment list does is it's going to list all the conda environments that you've created. So usually at the beginning, the first time, there's only one, base, right? And the conda base environment is just like a default environment that you have. So you run conda environment list, and it's going to give you the list of environments. Every time you create a new environment, it's going to be added to the list. Does that make sense? So every time you want to do a project. So that's usually the first command. The next command is going to be conda create. And then here you need to specify -- name. And then you're going to specify, and let me make this smaller. That's good enough. Conda create -- name. And then let's say pi35. And what that means, that's the name that you give it. So you can give it any name that you want. But the idea there is that you're saying, you know what, I need this because I need Python 3.5 specifically. For whatever reason, 3.5 only works with these libraries. And so I'm going to name it that, right? And once you do that, you can also specify the programs you're going to install. So for instance, here I'm going to say Python equal 3.5. You see that? And that this Python 3.5, what that means is the program that is going to install. So usually you just installed like the very first program, here, and then after that, you can add other dependencies that you might need. Remember, all of these are just going to be linked to the pi35 environment. Do you guys see that? Is this clear for everyone? All right, so once you run this command, you create the environment. So now you're going to do conda environment list, and that's going to list out. So now pi35 would appear, okay? But just because it's listed, it's not active, right? So because you can have 10 environments, 20 environments, however many you want. So what's the next step? The next step is, let's say that now you've created an environment. Now you want to go into that environment, okay? So now you're going to do conda activate, and you're going to activate the environment that you created. So in this case, pi35. Once you do that, what's going to happen is that the conda prompt that said base, now it's going to say pi35. And that just tells you, hey, you know what? Now I am in this environment. So everything that you do after that to install, it's only installed in the pi35 environment. But if you exit out to another one, or you exit out completely out of Anaconda, those programs are not installed on the Linux VM. You guys understand? Does that make sense? Any questions? That's basically it. After that, once you are done and you want to get out of an environment, you just do conda deactivate. You're going to do conda deactivate, and that gets you out of the Pi35 environment back to base, basically. If you want to remove an environment, let's say that you're done with the project, then you can just, and you have like 20 or more, so it's starting to get crowded. So you can do conda environment remove, and then you can do -- name Pi35, right? And that would allow you to remove it. And then, of course, if you want to do an install a program, there's various ways. You can do conda install, and then we can do something like matplotlib =, right? So you could do something like that. That would install a specific program just on that conda environment. Also, when you're in conda, you're already in that environment. You usually just do pip install, and then let's say like Keras or something, right? So that will also work. And remember, the beauty of this is that it only installs these dependencies on that environment. As you saw with the previous command, you can specify the version. So you can say conda install, what was it? Matplotlib =, right? So you can specify the versions, the specific dependencies for the environment. And they only exist within that environment. They don't exist in other ones. Docker is the thing I'll talk about in another lecture, is like taking this a step further, right? So Docker will be, like carrying things from one computer to another. But this is a very nice solution. And as you can see, there aren't that many commands. These are the main ones that you would use in general to set up your conda environment. Any questions on this one? Yeah, go ahead, please. They're not, this is not like GitHub. So GitHub is, you put your code up in this is purely local. Yes, this is purely your own machine. So this is when you'll probably have like a Mac, and you're working on your Mac, and you have multiple projects going on, right? So you have a web project, and you have certain libraries that you want in there, but then you have like Java in particular is problematic, right? So you can have that various versions, but it's all purely local. It's a good question. Yes, purely local. This should work on Mac. It works on my Mac. It should work on Linux. Oh, actually, Windows has this as well. I can show you because I forgot that I do have it here as well. So if you go after you've installed it, like I could have done this, I guess I forgot. You have this thing called the Anaconda prompt. So I just click on that one. So everyone, let's see if everyone is seeing that. But yeah, you can see that there. Actually, I forgot I had this. So this is actually the Anaconda environment. So if I do here conda environment list, it gives me all the ones that I have. These are my environments. Now, these environments are separate from the file system. So that's an important thing to understand, in the sense that here, this is the file system, right? And I can go to the desktop, right? See, I'm in the desktop right now, but I'm also in the Anaconda environment. So that's an important distinction. You can navigate and put your files wherever you want in the file system, but you can also say that I'm in this virtual environment where, that is only, it relates only to the things that are installed on the computer, not the files that you are editing or coding, in a sense. Do you guys understand? All right, yeah, that was a good question, actually. Let me tie my shoe. All right, so yeah, all right, I think that concludes Anaconda as far as the discussion, unless there's any questions. All right, so I'm going to go ahead and exit. All right, so the next thing we're going to do is let's actually navigate. Still here, as I said, we're just doing miscellaneous things. All right. So the next thing we can do, we're just going to do a little bit of scripting. Take a look at some additional final scripts for the semester. Kind of just things that I find like interesting or fun, maybe related to the Linux system. Okay. So let's start with a simple HTTP server. So you guys know about services in Linux, and you guys know that you create. How do you start the HTTP service in Linux? How do you start that one? What's the port number associated with it? 443 would be for HTTPS. 80, port 80, right? So we're talking about port 80, setting up a web server. So you're all familiar with that. So you usually do what? Sudo service Apache to start, something like that. And it starts the Apache web server. But let's say that, for instance, that you wanted to create your own little simple HTTP and assign it to a port number, right? So we could also do that. So let's say that you're going to create like an intranet of your organization and you want to serve some files. So let's go into this courses thing here. All right, so I have several files in here, as you know, and I want to create a server so that these are available via a browser somehow. So I'm going to go ahead and create a simple script. I'm going to call it simple HTTP, simple HTTP server. Oops, let's do this. Okay. .py. I'm going to increase the size. All right, so nano simple HTTP server.py. So I'm going to go ahead and create this. So I'm going to do import simple HTTP server. And then I'm going to do import socket server. Socket server. All right. And now I just have to basically invoke, create an object, a socket server object, and basically start up the service. So what it should do is it's going to serve some files. So I'm going to have to designate a port number that I want to use. So in this case, I'm going to use port 8000, port that's not currently being used. I'm going to create a handler. So I'm going to do handler. And this handler is going to be a simple HTTP. So it's going to be a simple HTTP server and dot simple HTTP request handler. Okay, so I'm going to create the object and then I'm going to link it to the port number. So I'm going to say HTTPD okay, and socket server, socket server dot TCP server. And I'm going to create a tuple here. So localhost. Okay. With port number. And we're going to associate the handler with it, the one that we just created here. Right, so I'm going to type that in there. Handler. Just like that. And now all we have to do is basically serve the page. So I'm going to call HTTP D dot serve underscore forever. Okay. Just one E. All right. So serve forever. So I'm going to go ahead and run this. Control X, Y. See if it gives us any errors. Oh yeah, Python 3. No module, simple HTTP header. So let's do pip install simple HTTP server. Let me do. Okay, let me see. If you guys find it before me, let me know. Now let me pause. You can see the screen. Yeah. All right. Yeah. Sorry. All right. So you guys should be able to see the screen now, I think. So what I was saying is, if you see, I'm going to kill it. All right. And then here, we just do a clear, repeat the process. So now to serve up that, to basically create a web server on port 9000 on this machine, I'm just going to run this command Python 3. Let's say I'm going to change the port to 7000. Okay, so I'm gonna start it up now, and then if I want to see the files, right? If I want to like deal with the files, I'm going to go over here, and now I'm going to do port 7000. Right, and you can see it's basically working, and I have really quickly a website with my files. This is, like I said, if you want to quickly do something on the intranet, etc. So that's the main idea with that. Really not that much. Any questions on that one? Nope. All right, a few other ones. We can go to the GitHub environment and just kind of take a look at them. So as you can see, I kind of went over this. I've gone over a few of these commands. A few other things to play with. I'll just kind of like talk through them. You can play with them. There are ways that you can tar and untar files. So there's the tar module. And this basically allows you to create a file, right? And untar it. So this is a module for that. So if you're creating, let's say, backups, right? If you're doing backups, let's say you created cron entries and you want to back up your files, but you want to back them up in a compressed fashion, you could use something like this script here, basically. Okay, you can see the script is basically doing a walk of the etc folder, finding the files in there, grabbing the files, and then basically adding them to this tar file to kind of compress it. So that's one of the scripts that I wanted to talk about a little bit. Other ideas are, some of these are not very practical, but they're just kind of to show you what you can do, like SSHing. There's a module called Paramico. There's many modules. And then this is basically to automate connections basically to an SSH service. You can see it's pretty intuitive: host name, port number, username and password, and then you can connect. Why would you do this? I mean, you know, that's a different story, but this is just example of things that you can do. So yeah, so compression, HTTP servers, SSH. This one is kind of nice. There, I wanted to show you this one. You can generate reports. So if you remember with SNMP, you were collecting data, right? And the data was being displayed basically on CACD, but that data could also be stored. And you could automate the process of generating reports, right? So if you wanted to generate like PDF reports that you're going to email to your boss or something, so that there's something called the reportlab.pdfgen module, and basically you import Canvas, and Canvas is literally like the document, right? And so in that document, you can create it, give it a name, right? And then decide what you're going to do, like adding specific things into it. So for instance, you do the text object.text lines, and now you start adding information into it. Or you do draw text, and then after that, you just save the file. So, very basic stuff, but this is yet another little script that you should be aware of. And I think the last one for today is basically, I think FTP interaction. So this is just like SSH. If you have an FTP server established somewhere and you want to connect to it and automate the process of uploading and downloading files, you can basically use it through this sequence. Okay, so this is, here we have the FTP library, and you're going to use it basically. So instead of manually connecting to FTP, you could do it automatically. Again, these I'm not demoing, as there's no real use case that I can think of for these, but just kind of FYI. All right, the last thing we're going to talk about today is this idea of geolocate. Okay, so I think I've mentioned this a couple of times in the semester. I'm just going to show you the code. If you have an interest, it's not homework. The code works and it's not very complex. So you can just run it. You will have to install, though, these packages. That's the only thing. Okay, but I kind of want to walk you through it if you have an interest in it, right? So it's not an assignment. So for this one, though, we will need Brightspace. So let me go to Brightspace for a sec, because there is a case in there. Okay, so I'm going to go in there. Right, and so I believe I have so this will kind of make it nice to be able to read through like a little case. I think it's case Aurora, if I'm not mistaken. Yeah. So let's take a look at case Aurora. Like I said, this is not homework, but just kind of motivates what's going on here. So as you can see today, I kind of went over these, right? Some of these at least, these problems. And then let's just talk about case Aurora. So it's really this short little scenario. So let's think about it. So I think everyone should be able to see this. All right, so Operation Aurora and how the obvious was missed. So this is a little bit of cybersecurity sysadmin thing. So on January 14th, 2010, the United States learned of a coordinated, sophisticated, and prolonged computer attack that targeted Google, Adobe, and over 30 Fortune 100 companies, including Bindi, McRae, and, oh no, sorry, that's the reference. This was dubbed Operation Aurora after a folder found in the infected machine. So that it was dubbed that, given that name. The attack used a novel exploit unseen before in the wild. Although Microsoft knew of the vulnerability, exploited in the attack, they falsely assumed that nobody else knew of the vulnerability, and therefore no mechanisms existed to detect such an attack. Okay, so it's a case of they've detected it, but they didn't know how to deal with it. To exploit and so the attack worked like this. To exploit their victims, the attackers initiated the attack by sending the victims an email with a link to a German website with malicious JavaScript. When users clicked on the link, this is called what, by the way, this type of an attack? When users clicked on the link, they would download a piece of malware that connected back to a command and control server located in Germany. From there, the attackers used their newly gained access to hunt for proprietary information stored on the exploited victim's system. You guys see? So there's some software, it's connecting to Germany, and it's looking for proprietary IP, I guess, intellectual property related things, trying to steal them. As obvious as this attack appears, it went undetected for several months and succeeded in penetrating the source code repositories of several Fortune 100 companies. Here's another reason, Nikita, why why you should not have your code on your own servers. Because in theory, GitHub or GitLab will have what? Better security than you. Would you agree? They're more targeted, but they also have more money specifically just for that. Because their whole business is, think about it, if your whole business is providing secure code and people are stealing your code, you're going to lose the business really fast. So they have a bigger interest. Whereas if you're a mom and pop shop, right, or even a small operation, how much do you think you budget to secure that code? Do you see what I'm saying? Yeah, go ahead. Yeah, go ahead. Yeah. Oh, yeah. Yeah. You see my point? I mean, it's up for debate without a doubt, but in general, you can disagree, but in general, that would be an assumption to consider for sure. Okay. All right. Anyway, so how was this? So the question would have been that I usually pose to the students is, but I kind of gave it away already. But so how would you solve this? How do you solve this one? Yeah, go ahead, Noah. But you don't know the vulnerability. You don't know how to prevent it. You don't know how to detect it. What could you do indirectly as a sysadmin to deal with something like this? Yes. They already clicked, unfortunately. Already happened. True, yeah. But they are, unfortunately, they already. Let's see, somebody said something here. Okay, so I'm getting a question here. Please look at the NAT configuration video that I posted that, that you guys should know by now. Yeah, so you need to make sure that you can ping between the two VMs by making sure you've done the configuration correctly using that video. But anyway, to answer the question here posed in Operation Aurora, the idea is, you could try to many things, right? Like, try to detect software somehow. But the solution here was that there's network traffic going to Germany. So if you do business with Germany, you can pinpoint where you're doing business. But another way of saying this, let's say that it wasn't Germany, it's Russia or somewhere where you've never done business. You can geolocate your network traffic. And what that means is printing out a report every week or having a map of the world and putting highlights of where your packets are going in the world. You see that? And if they're going to Germany, you might notice, or Russia or wherever, you might notice, okay, you know what? Boom, this is, why is traffic going there? Why is traffic going there at 3 a.m. in the morning? Why so much traffic is going there? You guys see that? And then you can spot those IP addresses and then just put them on the firewall so that to filter out. Yes, very good. Exactly. And so that was the solution actually to this case. And if you notice, the code for writing this is pretty straightforward. It's already on the GitHub, so you can try it out. I mean, I'm not going to make it a requirement at this point in the semester, given that the semester is over pretty much. But, it's something for you to play with if you want to just kind of get a feel for it over the summer, etc. So what you have to do is you install a couple of libraries. One in particular, if you notice, is the PyGeoIP. And basically what that is, it's a database for geolocation. So you have PyGeoIP, and then this has the geo.dat library, which will basically, by using this library, you can look up IPs that you're getting, right, and see what country they're associated with. Okay, so IPs, will be associated with specific countries. So here, what happens is, you load the database, you create a PCAP reader, which is, you're familiar with PCAPs because you've used them with Wireshark all semester. So you're obviously capturing, doing a TCP dump, etc., of PCAP files, right? So you can imagine how you set a cron entry, right? And then you maybe somewhere on your servers, you're capturing packets, creating that PCAP file, and then that PCAP file becomes the input to this, which basically you're going to, read the PCAPs, kind of, all the elements in the PCAP file, and then look up source, IP, source port, destination, and then notice you just send the specific ID to this function, retrieve geolocation. So that's this function, and this basically, if you notice, it's a very simple database lookup. So in gi.record by name, you plug in the IP, and then it'll return what country it is associated with. That's it. And then that way you can have if statements that, like highlight something in particular or so on. And you can implement this quite straightforwardly. Just cron entry with TCP dump, right? Save that PCAP file somewhere, and then another cron entry to run this script, read the PCAP file. And you're able to geolocate. I mean, in the most simple way, you're able to geolocate. All right, so anyway, so that's basically it today. So I'm going to stop the recording now.